Okay, here we have two types of materials. If I need to classify these types of materials into two groups, then they would be conductors or electrical conductors, which is the group above, and electrical insulators, which is the materials at the bottom, okay? Now, today we will focus more on the materials at the bottom, which are called electrical insulators, all right? So electrical insulators, do you think they have any form of electricity passing through them? Do you think charge can pass through insulators?
No.
No. Okay, great. Now, if I have this, if I'm looking at this, and the blue circles are basically nuclei, and the whole, round object is an atom, which group of atoms is conductors and which group of atoms is insulators?
The right is conductors and the left is insulator.
Yes, so these are atoms of conductors. How could you know, ya Mahmoud?
Because of the free moving electron.
Great, yes. So I can see that conductors have freely moving electrons, which are electrons that can, move along the metal, while insulators, they have their electrons bound to their nuclei. The electrons are just held or, like bound in the nuclei. They cannot move around, okay? So now, let's look at two insulators. This is before rubbing them. Any two insulators would be neutral. Now, when you rub, this causes the force of friction to cause some negative charge, which are electrons, to move from the cloth to the balloon. Okay? Notice that the positive charge did not move because it's protons, and protons are part of the nucleus, and they cannot move around. Now, after rubbing, the force of friction will cause some of the electrons in the outer shells, which are easiest to move, to be transferred from one material to another, which is, in this case, from the cloth to the balloon. Okay? Great. Now, rubbing causes friction, which causes electrons to move from the cloth to the balloon. Yes, Ahmed.
بس زيد ده هيجوين حالا.
Great. Okay, let's wait for him. How about Malik?
والله مالك مش بيرد على أمس
ماشي.
بس أهو ما بزيده.
Hi, Muhammad. Good morning. Can you hear me?
بس أعتقد هو عنده مشكلة في المايك يعني
محمد عنده مشكلة في المايك. طب يا محمد, if you can hear me, raise a hand or send anything in the chat. Okay, hi, ماشي. So, yeah, back to this again. Okay, Muhammad, تمام. We were just talking about rubbing two neutral insulators. Before rubbing, they're neutral. They have an equal number of protons and electrons. And we also talked about the only type of particles that can move, which is electrons. Electrons can move, protons cannot move. So if I rub these two materials, the force of friction will cause electrons to move from one material to another, okay, which is in this case from the cloth to the balloon, right? This is what the text says here. Now, when the balloon gains negative charge, now it's called negatively charged object. And when the cloth has lost electrons, it has more positive charges now. So it's called a positively charged material. All right. So what should happen next if I bring a negatively charged object close to a positively charged object? What should happen next? They should attract because they are opposite charges now, oppositely charged objects. Attraction is because unlike charges attract, But if I bring two balloons, which is the same material, and I charge them by rubbing, if I rub two balloons with two pieces of cloth, both balloons will be negatively charged because both balloons are made of the same material. So if I bring these two balloons closer, they're the same material, so they carry the same charge. They're both negatively charged, so they will repel. And the reason is because like charges repel. تمام؟ طيب, what would happen if I bring the two pieces of cloth closer together? And if I had like smaller pieces of them, because you can't have larger pieces interacting, they would be stopped. Two positively charged pieces of cloth will also repel because like charges repel, okay? Great, so we actually talked about this already. I just want to clarify that the charges here, even the electrons, when they travel from one material to another, they are held, or they are, they do not move, they do not flow through that material. So in our example here, when the electrons have traveled from the cloth to the balloon, the electrons would just build up or accumulate or stay on the surface of the balloon. They will not flow, they will not move through the balloon, okay? And the reason is because the balloon is an insulator. It's an insulating material. Insulators do not allow charges, even electrons, to move through them. So since electrons will not move, we call this a static charge buildup. Static means not moving, right? And this whole, science of studying static charges building up on insulators is called static electricity. So which type of electricity can I have in insulating materials or insulators? It is static electricity, okay? Charges cannot move. Electrons cannot move through it, cannot flow. They can only transfer from one material and stay there on the other material as a static or not moving or a built-up charge. Okay, now this rubbing is actually called charging. So if I ask you to charge a rod or charge a balloon or charge whatever the object is, how do you charge it? Everyone, how do I charge an insulator? How do I charge an insulator?
By
By rubbing.
rubbing them with each other.
Yes, by rubbing it with another insulator. Okay, this is called charging by rubbing, and we can do it to insulators. Okay, now I have a question for everyone. Now, which material object will lose electrons and which will gain when they are rubbed together? How do I know? مين فيهم اللي هتلوز مين اللي هتgain? Does anyone know?
The one getting rubbed will lose electrons, and the one that's not moving will gain the electrons.
Well, it doesn't depend on that because when you rub them together, it's the same thing. It's just, it's not that one of them is not being rubbed. It is being rubbed. You can say that the cloth is being rubbed to the rod, and the rod is also being rubbed to the cloth, okay? But you can tell by knowing which one is a better conductor. The better conductor will lose electrons because they can easily move off that conductor, and the better insulator will gain electrons. This is a very important fact to remember. A better conductor will lose electrons, and the better insulator will gain these electrons. طب يا مس ما هما الاثنين insulators. يعني ايه بقى better conductor? Materials, yes, they are insulators, but that doesn't mean they are not conducting at all. Materials can vary in their conductivity. Like even in insulators, if you compare them to one another, some of them are worse conductors or better insulators than others. And some of them are just poorer conductors. Like a better way to describe an insulator is to say that it's a poor conductor. It is a conductor, but very poor. And some materials are just more, or poorer than others in terms of conductivity. So these two materials, one of them is a better insulator than the other. And that better insulator is just greedy. It wants electrons. And the better conductor will lose electrons very easily because they can move in that better conductor somehow, not entirely move, okay? Let's do this question. The student, he's holding a charged plastic rod near a running tape. This is water. And the student observes the stream of water bending towards the plastic rod. Which of these following options shows the correct arrangement of charges in the stream of water?
D.
D, okay. What does everyone else think? Malik, Ahmed, Muhammad?
نعم مش
What's your answer to this question?
الأنسر اللي هي مش المفروض أمثل البوزيتيف تشارج كلهم يبقوا في ناحية واحدة. أيوه يبقى دي.
D, ماشي. So Ahmed, sorry, Muhammad sent the answer D. Mahmoud said D. Malik D. Ahmed
دي برضه.
D. برافو عليك. Yes. The answer is D because what happens is that the water is neutral. It has positive and negative charges. But what happens is that all the positive charges are now closer to the rod. بس positive charges do not move. طب ايه اللي حصل يا مس؟ هو ازاي البوزيتيف بقت قريبة للرod كده؟ اللي حصل ان الالكترونز هي اللي بقت repelled. Okay? So they were, you know, not arranged this way. They were just mixed. And now the electrons got repelled by the electrons in the rod. So the electrons moved to one side and the positive stayed. And now this has, or it is positively charged on one side and negatively charged on the other side. The water, again, is positively charged on one side and negatively charged on the other side. So as a conclusion, when neutral objects are brought near a charged object, مين النيوترال هنا في الإكزامبل بتاعي ده ومين الcharged؟
Neutral water charged rod.
Yes. So the neutral is the water because it had equal positive and negative. When it's brought near a charged object, which is the charged, negatively charged rod, what happens بقى؟ They become negatively charged on one side and positively charged on the other side. طيب وبعدين بصوا بقى دي. That's a new part and it's a very interesting part. Have you ever thought about whether the force of attraction is stronger or the force of repulsion? مين اللي stronger? Attraction or repulsion? Okay, let's look at this. Now, the unlike charges here, the positive and the negative on the rod, are closer together than the negative to the negative on the other side. These are closer, and these will experience attraction, and this is what makes the attraction forces always stronger than the repulsion forces. Why again? Because positive and negative here are closer together, so they just experience a stronger force. Attraction is stronger than repulsion. Does that make sense? Should I move on? Let me know.
Yes.
Yes, okay, everyone, let's move on.
ماشي يا مس.
هو ليه صعب الناس ترد على طول بس يعني مش عارفة. Okay, ماشي. Now, since we know this already, this was like the water in the previous question. It's neutral, and this is a negatively charged rod. So it will always experience attraction or repulsion if I have a neutral object next to a charged rod. What do you think?
Attraction.
Attraction, always attraction, okay? تمام, حلو قوي. طيب. Now, if I move that neutral object very far away from the charged rod, very far away, do you think it will experience any force?
No.
No. So why not? Why does it have to be a certain distance from the charged rod? Why does it have to be close enough? Does anyone know? This is like a magnet and a piece of iron, right? If the piece of iron is not close enough to the magnet, even if the magnet is okay and working properly, it wouldn't attract the piece of iron. Why is that?
Because it's far away from the magnetic field.
Thank you. Yes. So the field, there is an area around any charge. So we have negative charges here, and there is an area around these negative charges, which is called the electric field. Not the negative, not the magnetic field this time. It's called the electric field. It's basically a region where a charge experiences a force. Again, it's the region where a charge experiences a force. What does that mean? Here's the charge. Here's the region around the charge. And which type of force does this charge experience? It attracts the neutral object. So it experiences an attraction or a repulsion force. It depends on the charge, okay? And what's around it. So if you have a positive or a negative charge, it always experiences a force, which is either attraction or repulsion. Okay? So again, electric field is a region where the charge experiences a force. Type. Let's look at some diagrams because you're going to be asked to draw these diagrams. If you have a positive charge in like a circle like this, okay, this is a positively charged particle. What is the electric field around it? The positive charge is very similar to a North Pole in a magnet. So in a North Pole in a magnet, the magnetic field leaves from the North Pole to the South Pole. This is similar to it. A positive charge will just have the electric field emerging, or the lines just leave from a positive charge. They come out of it. Tamam? They come out of a positive charge and go to a negative charge. So a negative charge, whether it's a sphere or a particle, whatever it is, or even a plate, it will always receive the field lines. Notice how these lines of force go into a negatively charged particle. Like, what if I have both of them? I have two plates, a positively charged plate and a negatively charged plate. How would the electric field between them look like? You will see field lines leaving from the positively charged plate to the negatively charged plate. And notice how they are equally spaced. So these need to be parallel, straight, equally spaced. Again, they have to be straight. You could add curves to the sides, or you can make them all straight. It's okay. But again, they are straight, they are parallel, and they are equally spaced, okay? Now, the closer the field lines, the stronger the electric field is, which is again very similar to the magnetic field lines around a magnet. The more lines I have, the stronger the magnet. The more lines I have here in electric fields, the stronger the electric field between these two plates. تمام كده? Any questions here in this slide? No questions? Malik, you haven't said a word in a very long time.
معاك والله يا مس.
ماشي.
أنا حضرتك بتشرحي يعني.
طيب, I'm checking on you. طيب. دلوقتي بقى, a positive particle in an electric field will always move in the direction of the electric field lines. Remember the two plates and the electric field between them? طيب, what if a positive charge enters that field? It will always move in the direction of the electric field lines, because the field lines will always go from positive to negative, which makes sense. Do you know why? Because the positive charge will be repelled by the positive plate and will also be attracted by the negative plate. تمام? طيب, how about if I have a negative charge in that field? If it's a negative charge, makes sense that it will move in the opposite direction to the electric field lines. If the electric field lines go from positive plates to negative plates, the negative charge will go the opposite way because it gets repelled by the negative plate and attracted by the positive plate. تمام. Now, what if the charged object is brought closer or near to a conductor? يعني احنا كنا بنتكلم قبل كده عن insulators interacting together. طيب, what if I have an interaction between a charged object and a conductor. And remember, in conductors, they have freely moving electrons. Electrons can move without rubbing, without charging by rubbing. You don't have to rub them. They can just move, right? So let's look at some examples. The thing is, the electrons in the conductor will move. Why would they move? Because they're freely moving. You don't even have to rub them. You don't have to apply a force on them. You don't have to have friction with them. They can just move freely. طيب. Let's look at the first example. If the charged object is positive. Now, where's that charged object that I'm talking about? It's that rod, okay? This rod is an insulator that is charged and it has a positive charge. Now, if I bring this insulator near a sphere, at first, they wouldn't look like this, the charges. They would just be randomly arranged. Positive next to a negative, and then a negative next to another negative, then next to another positive. They would just be randomly arranged type. Once I bring the positively charged insulator rod or glass rod near that sphere, first thing happens is that you have this charge, separation, right? The positive charge would attract the electrons. And what is left in place? The positive charges. So we can say that, just like the water example, the water question, we will have one side of the sphere as negatively charged, and the other side of the sphere will be positively charged. تمام؟ ايه الحاجة الوحيدة اللي ممكن تتحرك في القصة دي كلها؟ It's the electrons. They can leave their places and move towards the positively charged glass rod. So let's review this again. Electrons are pulled towards the positively charged rod, which results in the conductor being negatively charged on one side and positively charged on the other side, okay? And since attraction is stronger than repulsion, why is attraction stronger than repulsion again? Because you have smaller distances here between the unlike charges, so they experience a stronger force than the repulsion force between the similar or like charges. So attraction is stronger, which causes the rod to experience attraction force to the conductor. The whole rod will be attracted to the sphere. Does that make sense? Yes, no? Does that make sense, everyone?
Yes, miss.
Abazid, Mahmoud, confirmed. Who else is following? Ahmed, Malik, I suppose you're listening. I don't know. ماشي. طيب هنعمل بقى حاجة ظريفة قوي. Malik, are you following? This part is very important.
مش معاك.
ماشي. هنعمل ايه بقى? What if the conductor, which is that sphere, is grounded or earthed? يعني ايه grounding or earthing? Grounding or earthing is basically connecting the sphere to the earth, like an earth wire, like using an earth wire. Yes? So if this sphere has an insulated, stem or rod, it's not earth type. If I replace this insulator with a conductor, like a copper wire, which I call the earth wire when it's connected to earth, then I can say the sphere is grounded or earthed. طيب ايه اللي هيحصل if the sphere is grounded or earthed? Can you just give this a wild guess? Keeping in mind that electrons are the only particles that are able to move. What do you think will happen if the sphere is connected to the ground or the earth? And I need to remind you that the ground or earth has, it's like a reservoir, or it's like a storage for charges. There's a lot of charges in earth. So if you connect a conductor between your sphere and the earth, there could be some charge exchange or travel or transfer.
Negative to positive.
Negative to positive? Do you mean electrons will move from the earth all the way through the earth wire and to the sphere? Yes. Do you see this positively charged rod لو انا فتحت له السكه بقى هو عايز more negative charges. طيب انا فتحت له السكه خلاص هو يقدر attract more negative charges منين؟ From Earth. If I have an earth wire connected to the earth and the earth has a lot of negative and positive charges, only negative will be able to travel or transfer all the way through the earth wire and to the sphere so they can get attracted to that greedy positively charged glass rod. So the positively charged glass rod would just attract negative charges from the ground. تمام؟ طيب وبعدين let's look at this here. First of all, I'm repeating the whole process. I'm repeating everything. I had a neutral sphere, which is a conductor, and I had a positively charged rod. I bring that positively charged rod close to the sphere, and it attracts the negative charges on the sphere and just leaves the positive on the other side. So I end up having a conducting sphere with negative charge on one side and positive charges on the other side. And I can say that the sphere is temporarily charged by induction. طيب وبعدين now what happens next is that I will connect my sphere, which is temporarily charged by induction, to the ground through an earth wire. And this will allow more electrons to be attracted from the ground through the earth wire and all the way to the sphere where they can get attracted to the positively charged rod. طيب, what if I remove the rod? When you remove the rod, now the sphere will be full of negative charges because it has gained some from the ground. So I can say that the sphere is permanently charged. When do you obtain a permanently charged sphere? When you both disconnect the earth wire, okay, so the charges cannot leave back to the earth again, and when you remove the rod, the positively charged rod away from it, okay? يبقى أنا هعمل إيه؟ هعمل disconnection للسفير دي، هبعد عنها كل حاجة بحيث إن كل التشارجز اللي عليها تفضل عليها. هبعد عنها ال positively charged rod وهبعد عنها أو disconnect the earth wire. So it cannot, it cannot allow the electrons to leave back to the ground again. This is called charging by induction. So in simple words, if I have insulators, I can charge them by rubbing. And if I have a conductor, I can charge it by induction. تمام كده؟ تمام ولا مش تمام يا حلوين؟
تمام مس.
تمام يا مس. Oh, someone left. مين؟ ده أحمد فتوت left. Okay. طيب. Now let's look at another example. If the charged object بقى اللي هو الرod ده لو هو كان negative إيه اللي هيحصل؟ بصوا لي كده. If I have the negatively charged rod and I bring it close to a neutral metal sphere, knowing that electrons are the only particles that can move, إيه اللي هيحصل؟ Electrons will leave, okay, and get repelled by the negatively charged rod. So they leave to one side of the sphere. And now the sphere is temporarily charged by induction. What does temporarily charged by induction mean? One side of it will be negatively charged and another side will be positively charged. It is charged, but temporarily. Why is it temporary? Because I still have, you can only have this when you have the negatively charged rod close to it. Once you move the charged rod away from the sphere, it gets back to being, neutral with random distribution of charge. طب وبعدين electrons are pushed away from the negatively charged rod, and the conductor will now be negatively charged on one side and positively charged on another side, which is called temporary charging by induction. And it's temporary because you always need the rod, the negatively charged rod, to be close to it. Once you remove it, it's back again. ماشي؟ And attraction is stronger than repulsion, so the rod will experience attraction to the conductor. طيب ما تيجوا نعمل حركة الearthing دي تاني. What if the conductor is grounded or earthed? ايه اللي هيحصل بقى المرة دي؟ I want you to guess. ايه اللي هيحصل يا مالك دلوقتي if I allow a pathway for charges from the ground? Do you think this rod will attract charges from the ground or repel to the ground?
هتتركت.
يعني هو negative. طب هيأتراكت ايه الرod ده؟ هيأتراكت ايه من الجراوند؟ عايز ايه من الجراوند؟ هيأتراكت positive. طب هي البوزيتيف تقدر تتحرك من الجراوند؟
لا
طب ايه بقى؟
مش هيحصل حاجة يعني.
لا هيحصل. قول لي، فكر تاني. ايوه.
repulsion.
ها.
يحصل repulsion.
هيحصل repulsion وبعدين these negative charges on the sphere, they have a way to move now. They can move to the earth. يبقى this repulsion between the rod and the negative charges will cause the negative charges to move through the earth wire and all the way to the ground. هينزلوا هما للground. Okay? So this is what happens here. First of all, you connect an earth wire, which will cause the negative charges on the sphere to leave through the earth wire and all the way to the ground. طيب كل ده لسه temporary charging. Once you remove the rod, which was pushing the electrons away, and once you remove the earth wire as well, now the sphere is left with positive charges. يبقى أنا عملت إيه للsphere دي؟ كان عندي neutral sphere. I made it positively charged. I charged the sphere. How did I charge the sphere? By induction or by rubbing? How did I charge that metal conducting sphere? By induction or by rubbing?
ده مين ده؟
By what? ما سمعتكش يا مالك. By induction or by rubbing? By induction. Induction is when you bring a charged object close to a metal, a conductor, so it either attracts from the ground or pushes to the ground. وايه اللي بيبقى attracted or repelled؟ electrons بس. تمام؟ So what happens is the negatively charged rod will pull electrons, will like push the electrons to the ground, repel the electrons. This word should be repel, okay? Here. Repel electrons to the ground, push them away. تمام؟ Makes sense? Okay. So the sphere becomes permanently positively charged by induction. تمام كده؟ ماشي. Now, let's look at another cool example. We're about to finish. Okay? طب I have two metal spheres. They were neutral. They had a random distribution of charges. And now I bring a positively charged rod next to them. مش أنا لما بيكون عندي one sphere, if you had one sphere, like in the previous example, you would have, a temporary charging, which is negative on one side, positive on one side. Like, if these are connected, they're touching, then I can think of them as one big sphere, where the negative charges will move towards the positively charged rod, and the positive charges will just stay in place and be on one side. And if I separate the two metal spheres, the negative will still be attracted and the positive will stay in place. And then after some time, they're unlike charges, so they will come together, or the charges will just be facing one another. تمام؟ طيب. Now, I just want to say that earthing doesn't necessarily mean connecting an earth wire. Earthing can typically be, be used, or you can see it in other questions as in contact with a metal. Yani if I want to earth this ball in the question, this ball, I want to earth it, I can either connect it to the earth with an earth wire or put it on a metal table, which is also a conductor, just like the earth wire. Okay, so this is a question in page 268. You have a light conducting ball and it's resting on a metal table. When the rod is brought close to the ball, as shown in the figure, the ball jumps up towards the rod. طيب, can someone explain to me why would the ball jump up to the rod? Hmm. Let's think together.
Because it's negatively charged.
The rod is negatively charged, so
So it will repel the ball.
it will repel the ball. Like, remember that the ball is metal, so electrons can move in that ball, right?
Yes.
So when there is a negative and positive on the ball, the negative on the ball can move away because it will be repelled by the rod. So the negative will move from the ball, بس هتفضل على البall دي؟ لا, it can transfer to the metal table, right? And from that
Mhm.
to the ground. So the rod will repel the negative charges on the ball and will just repel them to the ground, right?
Yes.
طيب, and then what happens to that ball now?
Become positively charged.
Yes, so I can say that the ball will become positively charged by induction. I need to mention that. So again, the rod repels the negative charges on the ball to the ground through the table. So the ball becomes positively charged by induction, right? Okay. طيب, now I have a positively charged ball and a negative rod. What happens between unlike charges? I have a positive ball and a negative rod. What happens between them? Abazid, yes, attraction. So the ball will just be attracted. The ball will be attracted to the rod. This is why it jumps up. تمام? Do I need to repeat this again? This is why the ball will jump up. طيب, the question says jumps, but it doesn't stay up forever. It has to fall. The next question in the page says, the ball touches the rod and then falls back down to the table. Do you know why? Because when it touches the rod, when it's attracted to the rod, it gains a negative charge from the rod, so it becomes neutral, right? So when the ball becomes neutral, then it doesn't have to be touching the rod anymore, and also it will be pulled down by gravity or by its weight. Again, when the ball touches the rod, it receives or gains negative charges from the rod, so it becomes neutral, and then it falls because of the pulling of gravity or because of its weight. تمام؟ طيب. The last part in this topic today, what if the metal, which is the sphere here in this example, is between two charged plates? I have a positively charged plate on one side and a negatively charged plate on the other side. How would the ball move? You know what happens? The ball oscillates or vibrates between the plates. طيب, how does this happen? First of all, this ball is painted by an aluminum paint, and aluminum is a conductor, so it just, I can say that the ball is conductor, okay? طيب. This means that the ball has freely moving electrons. طيب, these freely moving electrons, what do you think will happen to them? I have freely moving electrons on the ball, and I have a negatively charged plate and a positively charged plate. What would the negative charge that is movable on the ball, how would it move? How would it, like act? Are you thinking? I hope you're thinking.
The negative will cause the positive will cause the negative.
طيب, the positive cannot decide to do anything. The ball has positive and negative charges, but the positive cannot move. خلاص? But the negative will take the lead. The negative can move. So the negative decides what to do. The negative will be repelled by the negative plate, and will also be attracted by the positive plate. So you know what will happen? The whole polystyrene ball will be attracted or will move towards the positively charged metal plate. طيب, when this happens, the positively charged metal plate will just, do you know? I don't want to say the answer right away.
Will become neutral.
Okay, and then
and then the ball will move to
Would
the
move
middle
down.
again.
Yes. Like towards the negative plate.
Yes,
And it touches that negative plate, right?
yes.
Okay, and then gets repelled
Uh,
again and attracted by the positive charge, right?
yes.
Yes, type. I want you guys to do this question as homework in this page, which I'll send in the group. And we will review the homework